We'll pretend like we haven't heard anything
Okay.
you said.
Well, hello, everybody. Welcome to class. Okay, we are talking about PCR gels, and we have, in previous days, made all of our reactions up, and we are ready to run gels. So we ran Agarose Gels. This is one example, and here are our little wells. So it had 8 wells in this comb, so we like to call it. And the DNA ran from this would be the negative electrode to the positive electrode. And so DNA being negative attracts to positive, so it traveled in this direction. So that essentially means that stuff up here is big and it gets smaller and smaller and smaller. And so this lane actually had a ladder or a DNA marker loaded. And this one is from Thermo Fisher. And it's showing us where each one of these little bright spots, these bands, and approximately what base pairs they correspond to. So this one's really hard to see, was probably a little underloaded or stuff floated out. But I think we could see this one is probably the bright guy that's right there. And then if you go 2 up, there's another bright guy right there. So this is a crappy gel. It would be really hard to tell anything, but luckily for whoever's this is, they didn't get any bands anyways. So it doesn't matter if our ladder was super light. This is an example of something that the reaction didn't work. Maybe a reagent was bad. We don't know. And I had said previously, like this, looks like it was an ethidium soak. And so you could actually destain in your buffer, whatever you ran the gel in, 1xTBE, 1xTAE, whatever, to try to pull some of this background pink out of it. And it would just leave it behind in this ladder, and it would make it a little bit easier to see. Still not going to be great. Sometimes that just happens, and that kind of sucks. If you were worried that maybe each one of these stuff came out of the well, it pulled it out. Occasionally, if you don't have enough buffer over top of the gel, when you're loading, even though it has that glycerol stuff in it, it tends to, with capillary action, get pulled out of the wells if that little meniscus thing at the top of the gel, if you really just have enough buffer or just not quite enough. So it's possible that this reaction worked and there was plenty of ladder to begin with, but when these wells were loaded, actually stuff jumped out. And so what actually got run through the gel was maybe a third of what you wanted to. And so that resulted in us not being able to see too much. So this was just my little example. And then this should be the marker that's on all of these different gels. And our job is to find the bands, which we can't on this one, find the bands and tell me how big they are. We're going to go into our little groups. And so I'll just have you guys each, maybe work on 2 of the gels to start with. We don't need to go through all of them. Once you get the idea, you get the idea. So for example, this guy here, you can see down here, this is probably just primer dimers. That's where the primers end up very low on the gel because they're super small. This ladder is a little easier to see the bright guy, the bright guy, the bright guy, right? Just like bright, bright, and bright. And then where these bands run. So some of the gels are a little easier to see. This one's nice and clean. This one's pretty clean. I think all of them are much better than the one I showed because that's why I use it as an example. Some have multiple bands. Some just have one. So I would like you guys to tell me how big the bands are that you see on the gel, and then also show me on one of the gels and on the ladder where your fragment should run. And so remember, we looked up by our primers what fragment we're expecting, right? What size? I think mine was 512. So if I were going to tell you where I would see mine at this 500 mark on the ladder, and then I would figure out where that same bright 500 line is on this gel, and I'd make a little arrow. And since I made these in Google Slides on purpose, I planned ahead. Shocking, I know. You can actually draw right onto your slides. So if you take that Google Doc and make a copy of it so you have your very own, then you can annotate with all kinds of stuff. You can put in text, you can label it, you can play around, you can make this bigger, right? Or you can try to make it look like the exact same size as the gel, move it around, whatever, you know, whatever you want to do, overlap it at some point just so you can try to pick stuff out, or underlap in that case. Oh, Lord, you can move gels around. Whatever you guys want to do with your, oh, hello, where is he? There he is. Whatever you guys want to do to make it easier for you to sort of annotate these guys. And now here are the leaf blowers next door. So just in time for class. So I'm going to put you guys into, oh wait, before, I guess I should ask if you guys have questions. That would be appropriate. And I'm going to put you guys into little rooms. I think, I don't know how many of us are here. Two or three to a room, maybe 3 to a room. And I want you guys to each do a slide, a gel, but you can work together and help each other out. And then it's not so boring, like trying to do this all by yourself, right? We get in our little groups, talk to each other, help each other out, especially if anybody's not familiar with Google Slides and all the little, you know, icons and things that you can do. You don't have to go crazy, but you know, you could make it fun. So let me go back to my, where am I? Where am I? Who are these people? Let's break out rooms and let's us do, okay, we're gonna go 2 to 3 per room. I'm gonna make it, it's a random. And okay, can you guys see, does it tell you like room 1 or no? It just sends you to a room.
Yeah.
You just go to a room, you don't know what number you are.
No, we can usually see what group number we're in, or like
Okay.
what breakout room we're in.
I was just, let's see, how many do we have? We have 6, 2, 4, 6. Okay, here's the deal. In each room, you guys, the 3 of you or the 2 of you have to pick different, fight over which slide you want or which gel you want. And in each room, you can't do the same one. And then the other rooms, it doesn't matter if you're all doing the same one because you're not in the same room. So like, for example, if I were in room 3 with Mary and Sandy, then Mary would have to pick, let's say Mary picked number 5, Sandy couldn't also pick slide 5. And if you both want the same slide, then you have to do like rock, paper, scissors or something until you figure out, you know. Yeah, so.
Dr. Malone, are we editing the Google file directly?
Yeah, so make a copy of the Google Dealmeyer so that you're each editing your own. And then as long as you're not doing the same slide as the person in your room or the people in your room, then you guys can work together to help each other.
Okay, sounds good. Thank you.
Is that good? Are we ready to open and to see the surprise? Well, Mary and Sandy know they're together, but everybody else is a surprise. You never know who you're going to get.
Yes, let the bloodbath.
Yeah. Okay, and then there's also a.
Do I need a laptop for this?
What? Sorry. You need a laptop to do this? Is that what you said? Was that Keiko? Uh-oh, my internet's going shitty.
It was not me.
That was not you?
Hello?
Hello?
Sorry, my phone is.
Oh, okay. Yeah, no,
is
my
acting up.
internet. So in the event that you're on your phone, you don't have a laptop near you, then
Voice
just
is
do it
breaking up.
with your partner, with people in your class. It's just, you know, it's just for fun, because this would be like, right, if we actually did all the pipetting, this is, you'd get something, you turn the light on the gel box and you're like, oh, I have no idea. Or yay, or I don't remember what size I wanted, or why are there 5 bands here? So, you know, this is
Is your voice breaking up for you guys?
the surprise. Okay, I'm opening your rooms.
Yeah, it's hard to.
Is it bad?
Okay, thank you.
And then,
Yeah, you're
oh, it's
laggy.
laggy. Okay, yeah. Shit. Yeah, Hey Cup can't hear me. All right, I will type, I'll type into the boxes for the rooms or in the chat. Jared, you want to talk to me? Yeah.
Oh yeah. I had a question with my paper again.
Okay.
I'm not sure if you're you're still recording. I'm
Oh,
not
let
sure
me
if I should
stop. Yeah,
still-
because I don't need to for the breakout rooms anyways. While I'm sitting here picking my nose, it'll be recorded. Okay, hang on. Pause recording. I'm resuming. I have resumed. We are sharing. We are screen sharing and we are recording. Okay, so this was the guy from number 1, right? So this is our gel number 1. So if anybody had gel number 1, this one actually, some of the ladders on these really are hard to see. This one is pretty decent, which is nice. So if we just, I'm gonna move it over closer just so we can see a little better. Ding dong. And it's almost lined up with exactly what we see. So we can see this bright guy here. It's probably that bright guy right there. This guy, the 1500, is probably this one. Yeah, maybe. And then the 500 is probably this one, right? And then like we said, when we were talking about percentage of gels, we can't resolve down super low. So the lowest one on this says that it's a 1% gel and they can see the 75 base pair band. That's really, really hard to see, usually on 1% gels. TAE may be a little bit easier, but that guy's probably the smear right there. And so the primer dimers are going to be this stuff. And they usually run, so a primer dimer is just each of your primers on each other. So it should only be like a 25 base pair piece, which you wouldn't see. But because we put in such a huge excess of primers generally in all PCR products or reactions, excuse me, that they kind of make more secondary structure. It's not just each one is a nice, you know, complementing base paired little piece of 25 base pairs. They're all like clumped up together. So they get some of that tertiary secondary structure. And so they run slower through the gel than what their length actually suggests, because they're not all nice and, you know, out. So these guys are running a little smaller than what maybe the 75 is, but that's just because they're just a big giant clump of a whole bunch of primers, both your forward and reversed, all stuck together. And so if we were looking at what we see up here, 2 bands that we got from theoretically PCR, pretending these are all PCR gels, who knows, they could be it could be other stuff too. But just for our purposes of being able to figure out what's going on, it's nice. And so these 2 guys are about the same size. When you load a lot of DNA, it usually gets smearier. So this may have had a more of the reaction loaded, right? Because you can see there's more primer dimers here than here. This is a nice clean band. This one's kind of chunky, right? And it's got dragging his little tail there. But you can see they're probably just below this bright guy. They're closer to whoever is right below that bright guy. If the bright guy is 5,000, then that one's probably 4,000. So we would guess that these products were at 4,000 base pairs. Now, if that were my PCR, I would be sad because I was looking for something that was 512. If you remember back from my primers, that was my expected size. So I would be sad and I would say, well, I want something way down here, right? This is where I would expect it by this bright guy, which is 500. So these two lanes, we got nothing, right? There's nobody home in either of these. And in these two, we got something very big. So if I went back and looked at where my primers might misprime, remember that whole long list of what else they could sit on? I had some really big pieces, some that maybe were 1,000. I would assume there must be something around 4,000, or I totally messed something up completely. I made my primers completely wrong. And this is actually what I should expect because I made them wrong, or I typed them in backwards, or I did something crazy. So before I'd repeat anything, I'd go back and look at all of my complementary base pairing, re-blast my primers, make sure what I ordered was what we were blasting, right? Because it might look all great, you know, on the computer. And then when we type them into order the primers and actually physically get them, maybe that was a mistake. So you can go back and look at all of that stuff, make sure everything's fine. And if everything was ordered correctly, then in this case, because we didn't get anything where we wanted, we got something we didn't want, but we didn't get anything we wanted, we would need to lower our annealing temperature to make it easier for our primers to sit down. There are other parameters we could also change in PCR. There's magnesium components and all kinds of buffers and salts, but the first things we generally try is annealing temperature. And remember, we started with 5 degrees below our melting temperature, our lowest melting temperature of either one of the primers. And so we would just start, you know, maybe drop another big chunk, or try a couple different annealing temperatures and then run them all in one gel and see if we come up with anything in the region that we're supposed to. If you were looking for 4,000, woohoo, you win. Right, I don't think none of us were supposed to be making PCR that big. But again, this, you know, is just a gel, just so that you guys can get an idea. And again, you can see the pink stuff in the background. That is the ethidium stained in that gel. Okay. I think that one's a thumbs up. That makes sense to us. Okay. Woohoo, I got a thumb. Okay. And then, all right, so let's look at number 2. Number 2 looks nice and clean. Again, it's pink in the background, but some of this is just that you can see is the UV behind it. So you might be able to destain this a little bit to make this a little brighter, but this is probably as good as it gets, and it's pretty nice. So if we move this guy over just to help us out, and we spread him out a little bit to see if, whoa, we can make it similar in size to make it a little bit easier for us. I think he's a little taller. Right, come up there, maybe. That's pretty good. Right, and so then we can guess that this one's pretty bright. So I'm gonna guess that's this guy. And then it's 1, 2 for another bright, 1, 2, that one looks brighter than these two. And then there's 3 more up for a bright, 1, 2, 3, and there's another bright. So I would think this would be the 5,000, this one would be the 1,500, and this would be the 500. And so we have 2 nice bands here, and they are just a little bit above 1,500, far below 2,000. So if we were guessing, we had no idea what to expect, we'd say that might be like 1,600. Did I say 1,000? 100. Yeah, I think I said 1,000. Sorry. So 1,500 and 1,600, 1,550. It would also help us to know what we were expecting. Now, again, if it were my gel and I was looking for 500, I would be sad again because there's nothing down here. But these are such nice, clean bands that it's likely that whatever this gel was, this is the fragment they were looking for, right? That is what we were PCRing. We were PCRing our 1550, a 1600 base pair piece, and there it is. And so according to what we learned, I think it was our Jove videos, it was exciting, that you could gel extract this guy, just take this little piece, physically cut it out, do that gel extraction assay, and then be ready to have that fragment for our ligation to put it into our vector. Now, because this is so clean, and sometimes gel extraction causes issues. We sometimes lose lots of DNA. Sometimes the agarose interferes. Sometimes I don't know what goes on, but we have issues with cloning from gel extracted DNA. So our other option is to just use PCR cleanup and not gel extract. So what that means is, so let's say we set up our PCR reactions were 50 microliters. And when, I don't know if we talked about it, but we load about 20 microliters on a gel. That's all that's going to fit in these little wells, including the dye, right, to make it sink. And so what you have, so you keep your little tube with your other 30 microliters, and you say, woohoo, both of these look good. None of them have other stuff. This one looks a little bit smeary in the background. So if we were going to pick one, maybe we'd pick this one. It might just be because there was more loaded here than this one. But we would take that tube with the other 30 microliters and we just do a PCR cleanup kit. And that takes out all the primers and the salts and anything else that might interfere with the next step. And so what you get back is the pure DNA, everything in the tube. And so if we remember, what we see on a gel, what is stained by ethidium is just what is enough nanograms to actually stain and see, which is quite a bit. So if our PCR primer sat down anywhere else and did a little bit of priming or a little bit of amplifying, we might not see it. Those products might be here, we just can't visualize it. Like one molecule, you're never going to see one molecule of double-stranded DNA that was amplified. Okay, but they're probably in here. So that is the only issue when you're doing PCR cleanup is you could have other size fragments in there that, and again, when you're cloning, it's one molecule to one molecule. So you only need one. And if it's the one that's wrong that gets in your vector, you're sad. But it's much easier, at least in our experience, to screen for the right thing that ligated into your vector from a bacteria, because you get lots of bacteria. You can pick a whole bunch of them and easily see if you have the right size band in it, versus gel extraction, where sometimes then the cloning doesn't work at all, or it's very inefficient. So if you had lots of bands, like in some of the other ones, then we wouldn't want to do PCR cleanup. You'd have to gel extract or work on your PCR conditions until you only get that one single band. But this one would be a good candidate for the PCR cleanup. Okay, how about the next guy? Ooh, look at that guy. Okay, so this one will be a little bit harder to see the ladder, I think, but we're gonna make
Dr. Malone,
Yes,
if we have class, can we be excused?
yes, but of course,
All right,
yes.
thank you.
I forgot you have class at 12:30. Okay, well, we're almost done, so I won't drag everybody else out too much longer. But yeah, whenever you gotta run, you gotta run. It's all good. Okay, so we're gonna guess these are the bottoms. That's probably this bright guy. That's probably 500. I can't really tell who's in here for the 1500, but I'm gonna guess, I don't know, that one looks brightest to me up here, right? Which might be that guy, which would be the 5000. So this guy again is gonna be around that 4,000 or 5,000 base pairs. That would be my best guess. And again, if you're not looking for that, you're sad. If you are looking for that, you're happy. This is a smear, but for me, PCR cleanup always works way better than gel extraction. Gel extraction is always just a little bit of a crapshoot, whether you're gonna get stuff back or not. So I might just PCR clean up what's left in the tube and go for it. Our other option, right? We always want to keep our options open. Let's say we want to gel purify this. You're feeling good about the gel extraction kit. You're going to do a good job. Sometimes, again, it doesn't matter what you do. It's not you. It's just, I don't know. So you gel extract and you try to do your ligation and cloning, and let's say it doesn't work. You still have, as long as you don't throw out all your crap, you still have the tube with that other 30 microliters in it. You can then PCR clean that up, ligate, subclone, stick it into bacteria, pick lots of colonies, and screen for that size. Because you can see this smear, there's gonna be other size molecules of DNA in there that might clone into your vector, but then it's really easy to not use those. You just screen for that size. You can do restriction digest or you can do colony PCR, both of which are things that were on our list for the semester. We're not going to get to, but we'll definitely get to next semester. So in this case, you have options. You could gel purify, see if that works. If that doesn't work, then you can go back to PCR cleanup. PCR cleanup always works unless like there's a grievous error that you put the wrong chemical in or something. And transformations using our PCR transformation vector kit always works unless you kill the bacteria in the electroporation or at the competent cell stage. So when you watch those Joe videos and it said you arced and you popped and whatever, that kills bacteria. And then for chemical transformation or heat shock transformation, that's what they called it, heat shock. If you had the temperature wrong and you heat shock too high, they'll be dead. But that ligation reaction almost always works. So as long as there wasn't anything else grievous going on, PCR cleanup and that kit always gives you colonies. So that's happiness. Data is good. Okay. Should we do the pink one? Let's go through these so we can get you guys on your way. So again, this one is nice and clean. PCR primers down here, we can see a bright guy here, that's probably 500. This one is likely to be the 1500. This one up here is probably that 5000. This product right here is likely to be about 1500 base pairs. And I know some of us, or at least one of us, had a pretty big piece. And if that was you, you would be super happy. That's a nice big fat band. Again, it's a little smeary, right? But that could also be just because we loaded a lot. And so sometimes it doesn't run all nice and tight. But even if it was some mispriming and other stuff, I would probably do a PCR cleanup. But this is a nice chunky band, so it would be a candidate to gel purify. And then boom, we'd be good. If it's the wrong size and it's this nice big chunky band, again, that's when I would be suspicious of my primers or something that I did, because mispriming so well in one spot and no place else would be very odd, right? Like your primer should sit in your spot better than any place else because that's 100% complementary. Sitting elsewhere, when we looked at our little charts, it showed like there were base pairs that were missing, that were off. It should always sit where it should, 100% complementary before it's 80% complementary. Doesn't mean that doesn't happen, but I would be suspicious getting this nice big band if you were expecting it to be a different size. And then I'd also go back and make sure whatever ladder you loaded was actually the one you're using here. Like what if in the freezer you grabbed one and it wasn't the Thermo Fisher, even though it's called 1 KB marker, every company's has different sets of bands. So you might go back, look at the tube and go, oh, wait, this was New England Biolabs. Go look at that chart and be like, woohoo, it is the right size. I was using, the key to the wrong ladder. So sometimes we have to think. Okay, how about this guy? We do this guy? Ooh, look at all the bands on this one. That's a little scary. Right, again, this ladder's hard to see. So if you've learned nothing, you want to load enough ladder to make sure it's very clear, unless you really are so used to this ladder and you know exactly the sizes you're looking for and you're not going to be guessing. And then it's much easier. So I'm guessing these guys, the smeary stuff down here is probably this. Probably just didn't resolve well. So then 1, 2 lights, this dark one here is probably this 1500, right? So this piece is probably 1500. This piece is probably 2000 next to the 2000. This faint guy is probably 3, that's probably 4. This brighter guy is probably 5. So this band is probably 5,000. This one might be 4,000, 4,500. This one's probably 6,000 or 7,000. And then same with these guys over here. So again, if you were looking for this piece right here, that was like 1,500, and you have this big whopping band here, you'd have to gel extract it in order to clone that. If you, within the realm of possibility, you could PCR cleanup. And if you compare, this is probably, I would probably say this is a quarter of the intensity of this guy. It's a little less than half. So there's going to be 2 or 3 times more of this in your tube than this piece. So you'll have 3 or 4 times more colonies on your plate of the wrong thing than the correct thing. And so then that's just a lot more screening. And unfortunately, sometimes, even if it's half and half, for whatever reason, the world gives you everything you don't want. So you don't want to have to screen hundreds of colonies to find this piece, right? We probably wouldn't risk just doing a PCR cleanup, especially if it's your first round of PCR. We might just, in this case, we'd want to raise the temperature because we want to make this band go away and this one stay. So we want to make it harder for primers to sit in the wrong place. So you might be able to run, change the annealing temperature, make it 1 or 2 degrees higher, try again. Maybe then the band you want is there and this guy goes away, or he's a lot lighter. Then you could trust the PCR cleanup. And then this guy in the same way, right? I can't tell which ones are brighter, so I just have to make it up, but I would guess that this one is probably, I don't know, that one's pretty bright there. That could be bright. That could be bright. This is probably, just because we've seen this pattern before, this is probably the 5,000, right? This is probably 1,500, and this is 500? I don't know. We'd have to know what we were expecting. So let's pretend like if it were mine and this were the 500, then this would be a band that I'd want, because I wanted one about 512. But again, I'd need to do the gel purification. I wouldn't trust having all of this DNA in the PCR cleanup also to do the cloning. So I would just have to do a gel extraction. In this case, I might cut out these 2 together. And you want to cut as little agarose around them as possible. In the Joe video, they took a lot of agarose. That was way more than I would take from that, because anytime you have too much agarose, it interferes with downstream reactions, and the kits are supposed to clean it out, but sometimes it just clogs the filters and then you get no DNA back. You don't get agarose contamination, but you also don't get DNA. And if it doesn't, sometimes you get DNA and agarose contamination, and that is going to inhibit the reactions too. So gel extraction is a little bit of a pain in the ass. So I would probably redo my PCR again, trying to make these bands stand alone and these bands go away by increasing the temperature, making it harder for primers to sit. They should still sit where it's 100% complementary. They should just not sit where it was 80% complementary from our mismatch stuff. And then we're back to this lonely, sad, this lonely, sad guy. And remember, if we got 0 bands, like we think it was underloaded, we may have just misloaded. We could just run that other 20 microliters from our tube, right? We only loaded 20 microliters of our PCR product. We still have 30. If we really think it all washed out of here based on the ladder being super light, and let's say you loaded the appropriate amount of ladder, you had just used it, it wasn't too diluted, it wasn't a new one that somebody screwed up the 6x to 1x or something like that, then I might just, before I get crazy and start rerunning PCRs and work changing annealing temperatures and get nuts, I would just rerun a gel. I'd pour a new gel. I would, re-prep. I'd make sure my ladder had plenty, make sure we have enough covering in the buffer over the gel so you don't get that sucking out of the wells when you load, and try again before I mess with redoing the reactions, because that's nice and easy to do, is just to rerun a gel. So that is your Julia Child PCRing, right? We set up reactions and right out of the oven, look, it's a gel with bands on it, or not in this case. So I hope that was good. I hope you learned something. I'm gonna unrecord because then we'll just finish this. This will be our PCR